in the drought-stricken suburbs of Arizona, multi-billion-dollar construction projects are being frozen in place because there isn't enough water to mix the concrete or sustain the workforce. But here's what doesn't make sense. North America sits on the largest source of fresh surface water on the planet, the Great Lakes, which contain enough water to submerge the entire continental United States under nearly 10 feet of depth. Because this isn't really about a lack of water, it's about the brutal reality of physics and the terrifying energy cost of fighting gravity. Consider the Great Man-Made River in Libya. It is arguably the most expensive, most ambitious water project in human history. A network of pipes 13 feet in diameter buried under the Sahara Desert. It was designed to turn the desert green by pumping water from ancient underground aquifers to the coast. It worked, until it didn't. Today, as the system ages, the cost of maintaining the pressure required to move that water is becoming higher than the value of the food it grows. We are seeing a similar signal in China's South to North Water Transfer Project, a $70 billion endeavor that is struggling with the simple fact that water is incredibly heavy and moving it uphill requires more energy than some small nations consume. But water is heavy. 1 cubic meter weighs exactly 1 metric ton. If you want to move it from a wet region like the Great Lakes to a dry region like Phoenix, you aren't just moving a liquid, you are moving millions of tons of mass across mountain ranges. We built the California Aqueduct, which is the single largest consumer of electricity in the state of California. But here's the problem. As our energy grids become more strained and our water sources become more depleted, the cost per drop is skyrocketing. We are moving from a world where water was a utility to a world where water is a luxury item. But the physical constraint remains. Pumping water over the Rocky Mountains would require dozens of dedicated nuclear power plants just to keep the faucets running in Los Angeles. The early impacts are already here. We are seeing water bankruptcy in real time. In some parts of the world, it is now cheaper to move people to the water than it is to move water to the people. Large-scale agriculture is beginning to retreat from the desert. This failure cascades across every other system we rely on. When you can't move water, you can't cool data centers. When you can't cool data centers, the AI revolution hits a physical bottleneck. When you can't water crops, the global food supply becomes fragile. This forces a massive reorganization of where we build factories, where we grow food, and where we buy homes. The era of the engineered environment is hitting a hard limit. We cannot tech our way out of the weight of water.